In this lesson, we will learn about relative ID operation master. First of all, we will learn about the components of the security ID of an object, then how a relative ID is generated, and the relative ID pools. After that, we will learn about the relative ID operations master and what happens when the relative ID master down. Finally, we sum up the lesson with the keynotes. Let's learn about the components of the security ID of a security principal object. As you may know, each domain in an ID forest has its own security ID. For example, we can easily find the security ID of the root domain in this ID forest by using this command, and here is the domain security ID. When a DC of a domain creates a security principal object, such as a user, a computer, or a group, it attaches a unique security ID to the objects. For example, we create a new user in the root domain, and we can easily find the security ID of the user by using this command, and here is the security ID. As you can see, the security ID consists of two components: the domain security ID to identify its domain, and the relative ID that is unique in the domain. To understand how a relative ID is generated, we first need to know that each ID domain is allocated a global relative ID available pool. To avoid conflicts, only one DC in the domain can access the relative ID available pool. The DC is called relative ID master. Here is how a relative ID is generated. By default, the relative ID master allocates each DC in its domain a block of 500 relative IDs that can be used to assign to security principals. The RID next RID is the relative ID assigned to the most recent created object. A DC generates a new relative ID by increasing the RID next RID by 1, then assign it to the next security principal being created. For example, if we create a new security principal object on GPVDC10, the object will be assigned the relative ID of 1604. Let's learn about relative ID pools. As you may know, each domain controller maintains two relative ID pools. The first one is RID previous allocation pool, and the second one is RID allocation pool. When the DC creates a new security principal object, it will get a relative ID from the RID previous allocation pool to assign to the object. When the RID previous allocation pool is exhausted, it will update new relative IDs from RID allocation pool. Here is how a DC renews its relative ID pools. When the RID previous allocation pool falls below 50% threshold, for example, the RID next RID now is 1900, the DC issues a request to the relative ID master for additional relative IDs. Upon receiving the request, The relative ID master checks the all-ID available pool and reaches a pool of unallocated relative IDs based on the request. The relative ID master then assigns the pool to the requesting DC via the ID replication, and it updates the all IDs allocation pool of the requesting DC. As soon as the ORD previous allocation pool is exhausted, it will be updated from the ORD allocation pool. After the update, the ORD previous allocation pool will then be used to generate new relative IDs to assign to newly created security principals. For example, if we create a new security principal object on GPVDC10, the object will be assigned the relative ID of 3101. Let's check the relative ID pools in this ID domain by running this command. To run the command, we just move the cursor next to it and click on Run Selection. Now let's scroll up a little bit, and here is the relative ID information on lospvdc01 in the domain ncsa.activelifeskills.local, and the pool is allocated over 1 billion relative IDs, and currently GPV DC11 is the relative ID master. As you can see, the RID allocation pool and the RID previous allocation pool are the same because the RID previous allocation pool has not fell below 50% threshold, and lost PVDC01 can create new objects and assign the relative ID from 1601 to 2100, and it have already assigned the relative ID 1603 to the most recent object. If we create a new object on lost PVDC01 now, it will assign the relative ID of 1604. So let's create a new user with the name Active Life Skills by selecting this command and click on Run Selection. Now let's verify the user information by running this command. As you can see, the user Active Life Skills has been created with the sysid over here, and it has the relative ID of 1604. It works as expected. Now we can tell each ID domain has one relative ID master, which is the single DC responsible for managing the relative ID pools assigned to the domain and processing relative ID pool requests from all DCs within a given domain. Also, when moving objects from one domain to another domain, the relative ID master of the source domain is responsible for removing the objects from the source domain, and the relative ID master of the target domain is putting the objects to the target domain. So what happened when the relative ID master down? From the rows of the relative ID master, we can easily figure out that if the relative ID master is down long enough, then the relative ID pools of all the DCs in the domain will be exhausted, and the DC can no longer create new objects in that domain. And also, it is not possible to move objects from one domain to another domain when the relative ID master is unavailable. This is the end of this lesson. Let's read the keynotes